Hi, welcome back to mathematics class, students. Today in this class we are going to discuss one of the most important chapter of second PUC mathematics. As you all know, the first chapter which we start with the second PUC mathematics subject will be the chapter which is the continuation chapter of our first PUC mathematics, and that is relation sign functions. So today we want to start with the relation sign functions. Well, in this particular session, we are going to understand some of the basic concepts of first year relation sign functions, and on top of that, we will see what we are exactly going to do study in this second PUC relation sign functions. Well, before going to what exactly a relation is, first we'll try to understand from the basics, that is a set. Okay, so all of you know what is a set. If I ask a question, a set is a collection of objects, right? Well, we write a set something like this. Set A is equal to, we write 1, 2, 3, and 4, and 5, right? So this is one set, and I represented set in roster form. Well, there are two ways in which we can represent a set. One is roster form, and other one is a set builder form, right? So right now we have a set A containing 5 elements, which is represented in the roster form. So if I ask you what is n of A, then definitely you'll say it as 5, because you can see that there are 5 elements, right? So we know this concept, a set. Okay. Now let's say I have one more set. Let's say I have one more set, B is equal to, which contains A and B. So if I ask you what is n of B, then definitely it would be 2. So now we have these two sets. Okay. And there's one more concept of called as a subset, right? So let's say you have a set A which contains 1, 2, and 3. And if I ask you how to write a subset for this one, well, you all know that subset is a set in which the elements will be from the parent set. For example, I can write one subset something like this: set containing element 1. As you can see that this one is coming taken from the parent set, right? So similarly, I can write 2, I can write 3, or I can write 1, 2, I can write 2 and 3, I can write 1 and 3, and I can write 1, 2, 3, 4, 5, 6. Then I'll write 1, 2, 3, the same set itself, and the null set. So these are the subsets we can write for the set A. As you can see, 1, 2, 3, 4, 5, 6, 7, 8. So the number of elements in the set A was 3. And total how many subsets we got? You can see that we got total 8 subsets. So total number of subsets will be 8. And you all know that this can be easily get from the formula what we have exactly. You can see that there are total 3 elements in a set A. If a set contains 3 elements, then the number of subsets will be given by the formula 2 to the power n of A, right? So this gives me 2 to the power of 3, which is equal to 8. So that's how we got 8 subsets. So this is the one concept where we can come to know total number of subsets for a given set. For example, let me ask you a question. Let's say I have a set A, okay, and this contains nothing. Nothing means what? It's a special set, right? So this is called a null set. This is called a null set. Now if I ask you how many subsets I can write for this one, what would be your answer? Well, as you can see that the number of elements in this set will be 0, right? So now if you ask me the total number of subsets, what we can write is 2 to the power n of A. And that is nothing but 2 to the power of 0, which gives me 1. So I can have one subset for this particular empty set. This could be one competitive question we can expect in the exam. Well, now let's see the next part of this one. In the first year, we have seen a concept called as Cartesian product. Well, we have seen something called as Cartesian product. Well, let me give you some idea about it. What exactly Cartesian product is. Let's say you have a set A which contains 1, 2 and 3, and let's say set B which contains A and B. As you can see that, my dear friends, set A has 3 elements and set B has 2 elements. Okay, so now we define something called Cartesian product between A and B, which is written as A cross B, and which is a set collecting all the pairs of the elements from the set A to set B. And how do we write that? You all know it, right? So we write as 1 comma A. I took the first element. I'm trying to make the pairs of the set of B. So now this gives me 1 comma A. Then we have 1 comma B. Uske baad mein we'll write 2 comma A and 2 comma B. Then we have 3 comma A and 3 comma B. So this is how we write the Cartesian product between the two sets. Now the question comes, how many elements do we have in Cartesian product? You can see that 1, 2, 3, 4, 5, 6. Total 6 elements. How do we got 6 elements? You can see that number of elements in set A is 3 and the number of elements in set B is 2. Alright, so you can see that number of elements in A cross B, which we got answer as 6, and which is nothing but n of A multiplied by n of B. And that's how we got 2 into 3 becomes 6. Now we can expect one competitive question in this way. Question might be something like this. Let's say you have number of elements in set A is 3 and number of elements in set B is 0. Well, if a set containing 0 elements, then definitely it has to be a null set. Now if I ask you how many elements there will be in Cartesian product, what would your answer? Well, the answer is very simple. A cross B should be equal to n of A multiplied by n of B, so which is 3 into 0, matlab 0. So there will be no elements in the Cartesian product if we have a null set. Okay? Well, this is all fine. Till now, this is what we have studied in first PUC, that is 11th standard. Now the question comes, my dear students, what is a relation? So the relation exactly starts from this particular point. Well, we say that relation is always a subset of Cartesian product. Well, just now you got to know what's the meaning of Cartesian product, right? So relation is always a subset of Cartesian product. So it means that for this particular Cartesian product, you can see that there are 6 elements, right? So how many subsets I can write? You can see that 1, 2, 3, 4, 5, 6. Matlab total I got 6 elements in the cross product. And if you ask me how many subsets we can write, then I can say that you can write 2 to the power 6 subsets. Yes or no? For example, let's say one subset could be like this. Let me call it as 1 comma A, then 2 comma A and 3 comma A. This is one subset. Yes or no? Yeah, you can see that 1 comma A, which is there here, and 2 comma A, which is also here, and 3 comma A, which is also here. So I just wrote one subset, and this is called as a relation, So as you can see, my dear students, as I said, total we can write 2 to the power 6 subsets. Iska matlab hua, we can write total 2 to the power 6 relations, because the relation is nothing but a subset. It means that I can write for this particular cross product, I can write 2 to the power 6, matlab 64 different relations I can write. I hope you are getting my point. So let me conclude everything from this all, from the last 10 minutes, whatever we discussed. Relation is a subset of the Cartesian product. Am I clear? Perfect. Now, till here we have learnt in first PUC. Second PUC relations and functions starts with something called as types of relations. So now we'll understand the types of relations. Yeah. Types of relations. Basically, we have total 5 types, out of which the first two are not that important, but let's try to understand. So the first one will be empty relation. The first one will be empty relation. As the name says, you can easily tell what exactly it will be. A relation in which there are no element, no pairs at all. So such a relation is called as empty relation. Okay, perfect. Then we got universal relation. Universal relation. So what is universal relation? Well, as the name says, universal set. You can imagine first year ka set theory, right? So universal relation is the relation in which we will be having all the elements which were there in Cartesian product, exactly same elements will be there in this relation. So इसको बोलते हैं हम universal relation. For example, let me take a simple example for you guys. Let's say I have a set A. I have a set A which contains, let's say, 1, 2, and I'll write A, cross product. So what will be that? There will be 1, 2. Sorry, 1, we'll write 1, 1, 1, 2, and 2, 1, 2, 2. This is a Cartesian product. So when I say empty relation, which is R is equal to a null set. As you know that for every set, null set will be a subset. Yes or no by default. So similarly, this is a relation in which there will be no pairs. Now, for a universal relation, R is equal to, for this particular relation, whatever the elements we have, the same elements we will write here. So this becomes our universal relations. So these are the two default relations we'll be having for every Cartesian product. So these are not that important for exam perspective for both boards as well as competitive. And I forgot to tell you one more important thing, my dear students. What is the weightage of this particular chapter for a PUC board exam, for Karnataka board? Well, it goes like this. We get 1 mark 1 question, and we get 2 mark 1 question, 3 mark 1 question, and 5 mark 1 question. If you add all of them, see how much you'll get. 5 plus 3 is 8, 8 plus 2 is 10, 10 plus 1 is 11. Matlab total will be having 11 marks of weightage for this particular chapter. And this 3 mark question will be always from relations. This 3 mark will be always from the relations, and they'll ask the types of relations. Well, now just now we have seen these two relations. Okay. Yeah. Now we'll see the most important 3 relations. The first one will be reflexive. First one will be reflexive, and the second one will be symmetric, and the third one is transitive. Well, let's see what they are. The definition goes like this. A relation R in a set A is called a reflexive relation if A comma A belongs to R. Now you'll ask me, sir, what is this A? A is any element from the set A. A is any element from the set A. Now let's see. What is symmetric? Symmetric says that if A comma B belongs to R, then compulsorily B comma A should belong to R. Now we'll ask me a question again. Sir, what are this A and B? Again, it's quite similar. A and B both are from set A. Now let's see what the transitive relation says. It says that if A comma B belongs to R, and I have taken one pair, A comma B belongs to R, and B comma C also belongs to R, then if these two conditions satisfies, then if A comma C, matlab the first element and the last elements, in दोनों का pair, अगर if this also exists, this also belongs to R, then we say it as, then it is called reflexive. Okay, so again here you can see that A, B and C all will be from set A. Yeah, I can understand that it's very difficult to understand by the definitions. What we'll do is we'll take one question and we'll try to understand what exactly it means. Okay, so let's pause the video and take the screenshot of this particular page. Yeah, so let's take one question, dear students. Question is something like this. I'll be taking question from your NCERT textbook itself. So the question is, a relation R defined on the set A which contains the elements, let's say 1, 2, 3, 4 up to 13 and 14. So this is your set A. Okay. Now we have a relation R which is written something like this: x comma y such that 3x minus y is equal to 0, where x comma y both are from set A. Okay, so now we need to check whether this particular relation is reflexive, symmetric and transitive. So let's see how it can be done. The first thing is, the relation R is given in the set builder form. It's given in the set builder form. So first our job is to somehow try to make it in the roster form, and you have done such questions in first PUC, right? Exactly. Now let's see, the given condition is something like this: 3x minus y is equal to 0, and I can write it as 3x is equal to y. Yes or no? Absolutely. So now what I'll do is I'll start picking the values for x. And what is x? As you can see, my dear students, both x and y are from set A. You can choose any any element you want from the set A. Well, I'll choose x as 1. So if I choose x as 1, we get the value of y automatically. How? Because we have the condition. So if you put x as 1 here, you can see that y is equal to 3 into 1 will be 3. Perfect. So we got a first pair. I hope you're getting my point, right? If you're not getting, you can pause the video and come back and you can see the video again. Let's see. If I take x as 2, so you can see 3 into 2 will be 6. If I take x as 3, 3 3s are 9. If you take x as 4, 4 is are 12. If you take x as 5, you get 15. Oh, we got a problem. What's the problem? The problem is, till here it was fine. This is x and this is y. Both are there in our set A. The problem is if I go to this particular pair 5 and 15, which is not there in this 15 is not there in our set A. Matlab I can't take this one. I can't take that pair. So I have to end here only. I hope you got my point. Well, we got a relation now. Now comes the important part. Now comes our important part. What is that? We need to check for reflexive. Well, the definition of reflexive says that, listen carefully, the definition of reflexive says that whatever the elements I have in set A, I should have the same pair. Matlab, let's say you have 1 here. So 1, 1, the pair containing the same elements, 1, 1 should be there in this relation. Also 2, 2, 3, 3, all the elements should have their pairs. If we have all the pairs, then only we can call it as a reflexive. So someone may ask me, sir, what if I have only 1, 1? It does not work. For every element, there should be the same pair. So as you can see that there is not a single pair also. So we'll write as 1, 1 does not belongs to R, इसलिए R is not reflexive. R is not reflexive. Well, I hope it's crystal clear now. Now let's see what is symmetric. What is symmetric? Yeah. How do you start a symmetric? First, what you have to do is you have to take one pair from this relation, any one pair of your choice. Okay, let me take 1 comma 3. 1 comma 3 which belongs to R. Okay. So now what we have to check is, can we have iska ulta pair? Matlab, I have 1 comma 3. Do I have 3 comma 1? You can see that there is no 3 comma 1. But 3 comma 1 does not belong to R. Therefore, R is not symmetric. So it's very important, my dear students, that for every pair in this relation, there has to be iska ulta pair. Remember, for every pair there has to be ulta pair. Even if one is missing, it is not going to be symmetric. I hope you're getting my point. Well, let's see the last one, transitive. Let's see the last one, transitive. How do you check for transitive? First thing what you do is, you take one pair from that particular relation. Okay, I'll take 1 comma 3. 1 comma 3 belongs to R. You took one pair. Next thing what you do is, you start taking the other pair. And very important thing is, if you are taken the first pair as 1 comma 3, the second pair should start from 3. That's a condition. Because the definition says A comma B belongs to R and B comma C. So the second pair, I can see that here you are like the second element in the pair is 3. And here you have to check for the pair which starts with 3. As you can see that this is the one which is starting with 3. So 1 comma 3 belongs to R. Even 3 comma 9 belongs to R. Now what we need to see is, this first element and this one. Do we have the pair of these two? Do we have the pair? You can see that 1 comma 9 does not belongs to R. It does not belongs to R. So that's why we say, therefore, R is not transitive. I hope you understood. Alright. Well, so what you have to do now is, you understood the concepts, right? So there are a couple of questions which are very, very simple in NCERT. So the first exercise, 1.1, there are a couple of questions which are exactly the same type. So what you have to do is to try them. You have to try them, and if you're not getting the answers of any of the questions, you have to write in the comment box so that we'll come to know. And in the next session when we start off with those questions first, and then we'll go to the next topic in this particular chapter. Okay? I hope this session helped you. We'll meet again in the next session. Till then, take care and bye-bye.